Let's think about what we know about decimal fractions so far. Remember, we have this decimal notation where we write, for example, 23,417 1/100ths as 234.17. And notice that this part before the decimal point, we read it as a whole number. And we looked at that a little bit more, and we justified that by saying that as a mixed number, 23,417 1/100ths was 234 and 17 1/100ths. How did we know that? Well, we described this in terms of division at the time, but we can think of this as the following idea. 23,417 is 23,400 plus another 17. This sum is easy to see. And so if we have 23,417 1/100ths, well, we have 23,400 plus 17 1/100ths. But remember, when we add fractions, we just add together the numerators. So this is the same as 23,400 1/100ths plus 17 1/100ths. This fraction we can now simplify by canceling common factors of 10. And we get that this is, in fact, 234 and 17 1/100ths. So what was our key move here? Well, it was splitting up this whole number as this sum. Now this should remind you of something. This should remind you, kind of expanded form. Let's see what happens if we take this decimal fraction and write its numerator fully in expanded form. In expanded form, 23,417 is 20,000s plus 3,000s plus 400s plus 110 plus 7 ones. So this fraction then, 23,417 1/100ths, is 20,000 1/100ths plus 3,000 1/100ths plus 400 1/100ths plus 10 1/100ths plus 7 1/100ths. Look what happens if I go through and simplify each of these fractions by canceling common factors of 10. Here I get the whole number 200. Here I get the whole number 30. Here I get the whole number 4. And what do I get over here? I get 1/10, and I get, there's nothing I can do here, 7 1/100ths. Now this we recognize as the expanded form of 234. This then is the expanded form of the decimal part. And that in turn lets us describe the place value of those places to the right of the decimal point. Just as we see that this place represents a number of hundreds, this a number of tens, and this a number of single units, we see that this digit represents a number of tenths, and this digit represents a number of hundredths. If we continued on, I hope it's easy to see we would get a number of thousandths, a number of 10,000ths, and so on. So decimal place values follow the same sequence as the whole numbers, in reverse, starting with tenths. So just to orient ourselves, remember that to the left of the decimal point we have the units or ones place, the tens place, the hundreds, then the thousands, and so on. To the right of the decimal place, there's no oneths place. Denominator 1, that's just whole things. So we begin with tenths and then hundredths. After the hundredths, we have a ones, tens, hundreds cycle in a thousands group. Notice the THs at the end. These are referring to the actual denominators of fractions. And then beyond the hundred thousandths, to the left beyond the hundred thousands, we have millions. To the right beyond the hundred thousandths, we have millionths, and so on. Beyond the millionths group, we have a billionths group and a trillionths group. Just as beyond the millions group, we have a billions group and a trillions group. And we can always recover this information about the place value of a certain digit by looking at the expanded form. This information is just a summary of what we see in the expanded form. So let's consider a decimal number, 208.10045. What I'm going to do with this number is write it in expanded form and then identify the place that the digit 4 appears in. So the expanded form, let's go to fraction notation. We'll have 208.10045 over, let's see, 1, 2, 3, 4, 5 digits to the right of the decimal point. 1, 2, 3, 4, 5 zeros in the denominator. So I'll have 20,810,045 hundred thousandths. Writing the numerator in expanded form, I'll have 20 million hundred thousandths. The millions digit is 0, so I don't need that. The hundred thousandths digit is 8, so 800 thousandths. There's a 1 in the 10,000s place, and then a 4 in the tens place, and a 5 in the ones place. Simplifying each of these fractions by canceling a common 10, I'll have 2 hundreds, 8 ones, 1 tenth, 4 over 1 followed by 1, 2, 3, 4 zeros, so 10,000, and 500 thousandths. This then is the expanded form of my decimal. This 4, what does this 4 represent? It represents some number of 10 thousandths. And we can see that in the original number, tenths, hundredths, thousandths, 10 thousandths. And again, why isn't there a oneths? The fractions with 1 in the denominator, those represent whole units. I'm going to give you one of these to try. Take the number 17.025, write it in an expanded form, and then identify the place the digit 2 appears in. Pause the video and try this now. Alright, so in fraction form, this number has numerator 17,025. Denominator is 1 followed by 3 zeros, so 1,000. Writing the numerator in expanded form then, I'll have 10,000, 1,000ths, plus 7,000, 1,000ths, plus 20, 1,000ths, plus 5, 1,000ths. Canceling several common factors of 10, what am I left with? 10 plus 7 plus 2 100ths plus 5 1,000ths. What place is the 2 in? In the expanded form, it looks like 2 should represent a number of hundredths. And indeed, I see tenths, hundredths.